really a lot about enzymes. So if this is, I'm going to say this one more time because it really needs to be clear, and then I'm going to go through exactly what I need you to know about how that happens. This enzyme, reactions, it would be nice if you know, this grabs onto this and this grabs onto this, and they're predeterminedly brought together by some outside forces or some machines or something. No. Everything that's happening in your cell is probability. It's just the odds of whether these reactions need to happen. All these enzymes do is increase the probability that these other collisions are going to happen. So if you increase the probability, more of them happen at the same time than if they weren't organized that way. Does that make sense? These reactions can still run on their own. It's just much less likely that they're going to run into each other like this. It's much more likely that they're going to run into each other like this, or like that, or some other way. The enzyme holds it so that it runs into it like this more often than not. Okay. All right, so what are enzymes? They're globular proteins. They have an active site. The active site is where the substrate binds to the enzyme. That is, if you think about, we'll talk about the lock and key model in a second. The lock and key model, that's the old place where the enzyme is the key. The substrate is the key, which fits into the lock, which is the enzyme. It's the shape. The triangle has to match the triangle. The circle has to match the circle. Okay, so what are cofactors? Cofactors are non-protein molecules that either temporarily or permanently are bound to the enzyme at a site other than the active site. And that allows the enzyme to bind to the substrate. Some of these are permanently attached to the enzyme. Some of them come in and change the way that it's shaped. Some of them are attached to the enzyme to provide accessory energy because there's energy needed somewhere in the reaction. So organic molecules can be cofactors. Cations, which are positively charged ions, metal ions, like minerals, we're going to talk a lot about those in 417b, can be cofactors. Other cofactors, vitamins are often cofactors. So again, we'll do the specifics of those next time, but there's some good examples of cofactors. So, how do enzymes and substrates fit together? So, what we just talked about is the lock and key model. You have a shape, right? You've got an oval, and the substrate has to be an oval. If the substrate is a triangle, even if it runs into that enzyme, it's going to bounce off the oval and go find a triangle. And again, it's all just probability. All these things are just swirling around in the cytosol and this space. And are they running in? If they run in, are they running in the right way? Are they, do they catch each other? And that's where the induced fit model comes in. So instead of the idea that these things are exactly the right shape all the time, the induced fit model says that, so here, this thing is generally sitting in an ovalish shape. But it's not exactly the right shape for the substrate. When the substrate gets close, there are these little tiny bonds that are temporary that happen that allow the active site on the enzyme to expand in such a way that it fits the substrate. So it is a lock and key model, but it introduces some flexibility into the way this works. Because it may be that it costs the cell, that there's more stress on the bonds in the enzyme when it's big, when that active site is big enough to hold the substrate versus not. It might just collapse down on itself a little bit. But when the substrate comes close, and when we say close proximity, we're talking nanometers. We're talking really close proximity. There's chemical interaction that happens, and these bonds change a little bit, and then it's like a gloved fit. Okay, so that's the difference between an induced fit and a lock and key model. Lock and key says that it's always in the same shape. An induced fit says there's a little variability in the active site that's changed by the substrate coming close. Questions on the difference between those?